Hi everyone, welcome to my channel Student the Brand. Today we are discussing about electricity. So here you can see electric current. It's very important in 10th class. Electricity. Electricity you can see. So that is also nothing but electric current. So what is electric current? So I equal to Q by T. The rate of flow of charge is known as electric current. I equal to Q by T. So here we can consider I is the current, I is the current, Q is the charge, Q is the charge, and so T is the time we can consider. Okay. So this is about electric current I am considering. So we can also take electric current I, that is 1 ampere. So SI unit of current is 1 ampere and SI unit of charge is coulomb and SI unit of time is second. So we can take SI unit of current will be defined 1 ampere equal to 1 coulomb of charge flowing through unit cross sectional area per second. So that will be considered SI unit of electric current. So I hope it is clear. Once again, electric current is nothing but the rate of flow of charge. So I equal to Q by T. I is the current, I is the current, Q is the charge, T is the time. Understood? So I hope it is clear. Now we can go to the potential difference. So what is the potential difference? So we'll talk about potential difference. Potential difference. So what is the potential difference? Generally, if you take the wire, so I'm taking this straight wire. So it's a copper wire also I'm considering. It's a copper wire. Electrons are there. So inside of it, electron. Will electrons will flow without any external force? Will it flow? No. Some force is required to flow the electrons. Some difference. Normally here you can consider I am taking the two beakers. So these are the two beakers. In these two beakers, so I fill the water until the top. So here I am filling the. So I fill the water until the top. So here also I fill. Then you can consider. So will water will flow? So from one beaker to another beaker? No, because both are at equal level. Both are at equal level. So we can't say the water cannot flow from one beaker to another beaker. So if you create some difference, if you create so one beaker certain height, so I'm taking like this, another beaker certain less height compared to first one, or you can take little down also fine, that's okay. Here I'm considering can take here, so I'm taking like this, okay. So I'm taking the beaker here, right. So if you connect these two beakers, what happens? Some difference will be there. Some difference will be there. Then the water will flow. So by the pressure difference, so it is certain height will be there. Here will be less height will be there. So because of that reason, so because of the difference, the water will flow from beaker 1 to beaker 2. Same thing. So because here difference is there, here it is the difference is not there. So here water will not flow from one beaker to another beaker. But here water will flow from one beaker to another beaker. So likewise, so if you take the conductor copper wire, so I'm taking this copper wire. So inside electrons will be there. So will electrons will flow with itself? No, it won't flow. Some difference will be there. So what it will be creating? That is battery. Battery. So okay, if you connect a battery to the circuit, automatically that will create the pressure difference. Because of that reason, electrons will flow in the wire. Okay, so I hope it is clear to you. Then, so simply we can say potential difference is nothing but difference in electrical pressure. Difference in electrical pressure. Simply we can consider, so V equal to W by Q. So work done to bring unit positive charge. So if you take this conductor, I'm taking this the conductor. Work done to bring unit positive charge from one point to another point. So I'm taking this point A and I'm considering this a point B. So work done to bring unit positive charge from point A to point B within the conductor. So that is called, we can consider that is potential difference. That is potential difference. Work done to bring unit positive charge from one point to another point. Within the field we can consider. Within the field also we can take, that is potential difference. Electrical potential. So here I am saying this is the potential difference, right? So then, and one more point is there, that is electrical potential. So what is electrical potential? So you understood about potential difference. So what is electrical potential? Is it same? No. So electrical potential means work done to bring unit positive charge. Unit positive charge from infinity to the required field. So I'm considering this the field. So you can I'm considering field A. So from infinity to the required field. So that is called electrical potential. Same SI units, everything will be same, but definition is work done to bring unit positive charge from infinity to the required field, that is called electrical potential. Okay, so unit will be same, that is SI unit is volt, right? So here you can see SI unit we will discuss. So what is SI unit? Potential difference here 1 joule by 1 coulomb. So 1 volt is defined as 1 joule of work is done to bring 1 coulomb of charge from one point to another point. That is electrical potential. That is electrical potential. So I hope it is clear to you. Alright. Next one we will talk about cell, battery. So electrical components. What are the components we'll use in circuit diagram? Circuit schematic, or simply we can consider schematic diagram. That is, one is cell. So one positive terminal and one negative terminal. This is cell. And I am considering one more, it is battery. One more it is battery I am taking. So this is the battery. So two or more cells will be added. That is battery. Here it is cell. So this is cell. So this is considered as a battery. And next one we can take switch. This is open switch. If dot is not there, that is open switch. If dot is there, that is closed switch. So inside dot will be there. That is, this is a open switch. Open switch. Open switch. Here it is closed switch. Closed switch. Right? Closed switch. Next one, we can consider a ammeter. So this is the ammeter we am taking. So positive terminal, negative terminal. Voltmeter. So voltmeter I am considering here. Positive terminal, negative terminal. And galvanometer also there. Galvanometer G I am taking here. Right? So positive terminal, negative terminal. Ammeter. So what is use of ammeter? To measure the current in the circuit. So voltmeter means potential difference. So to measure current, here to measure the potential difference. Here to check whether the current is flowing in the circuit or not. The current is flowing in the circuit or not. So it will check, that is the galvanometer. So I hope it is clear. Next one, we can also go through that Ohm's law. So Ohm's law I will explain the definition today. Ohm's law. I'll give the definition today. Next class will go with the activities in series and parallel. Next one will go with the potential electrical power, everything. So what is that? So when you take, so I'm considering this battery. I'm taking the battery. I'm considering here. So ammeter here. Ammeter I'm taking, and one more thing here. Resistor I am considering. This is the resistor, and here switch if you take. So here I am taking, right? So here 4 cells you can take, and like this. So actually this is the circuit diagram. So experimental setup of Ohm's law. So you can take this, each cell we have to add each and every time. So until here only it will be there. this will be joined, and this will be connected likewise. So here this is one cell, one, two, three, four cells. We are concerned current is passing through it. So this closer switch, when switch is closed, current will pass. So here across this resistor, so potential difference, that is voltmeter, will be joined. So here I am taking positive, negative, and positive, negative. So here experimental supply is very very important. So here you can see now when the current is flowing, so when you on the switch, automatically current will pass through it. So when the current is passing through the resistor, so this is a resistor, that is nothing but a nichrome wire. So this is the resistor. So here I am considering this is a resistor. Okay. When the current is passing through, when you on the switch, automatically current will pass through the circuit. So current is passing through the resistor. So the potential difference across the resistor is directly proportional to current flowing through it. So V is directly proportional to I. V equal to IR. So that is nothing but so Ohm's law. Once again, when the current is passing through the conductor, or simply we can say resistor, here conductor we can say, when the current is passing through the conductor, the potential difference across the conductor is directly proportional to current flowing through it. So V is directly proportional to I, V equal to IR. So from this we can take I equal to V by R, I equal to, so here I equal to V by R, you can also take, right? So I equal to V by R, or R equal to V by I. So likewise we can consider. So this activity completely activity is very very important. So in the next class I will explain about activity and series and parallel everything, and we will do some problems also based on it. So stay tuned, watch, and regularly follow to Student the Brand. So you'll get more concepts. Okay, so like, share and subscribe to Student the Brand. Thank you so much. Yours, Student the Brand.